Hello everyone. Today we are going to learn about the workability of fresh concrete. Let's look at a real case. A serious engineering quality accident occurred in a bridge pier, where 13 out of 14 pier columns exhibited severe honeycombing, with exposed reinforcement in the honeycombed areas. Concrete was found to be involved in the following issues during the construction review. So, what properties or qualities does concrete need to possess? Today, the teacher will reveal them one by one to the students. Concrete is an artificial stone, formed by mixing cementitious materials, aggregates, water, and appropriate admixtures and additives, and then hardening. Considering factors such as the structural characteristics of buildings, properties of raw materials, construction techniques and equipment, construction environment, and quality management, fresh concrete needs good workability for mixing, transporting, pouring, and compacting. Hardened concrete, after curing and solidification, requires sufficient strength, certain deformability, and excellent durability to ensure long-term safety use. Next, we will learn about the properties of fresh concrete workability, also known as its ability to be worked. First, let's look at the definition of workability. Concrete's ability to be easily worked during all stages of construction, ensuring uniform quality and cohesion of its components, and compactness of its form. The workability of a concrete mix indicates the ease of construction operation and its resistance to segregation. Workability is a comprehensive concept composed of properties such as fluidity, cohesion, and water retention. The interrelationship and contradiction among these properties are unified under the concept of workability. Fluidity, also known as consistency, refers to the ability of a concrete mix to flow and fill molds uniformly, under its own weight or during compaction by construction machinery, reaching all corners evenly. Good fluidity facilitates ease of operation, compaction, and molding. The magnitude of fluidity reflects the consistency of the concrete mix, directly affecting the ease of pouring and compaction as well as the quality of concrete. Depending on construction requirements, fluidity is classified as stiff concrete, slump 0 to 10 millimeters, plastic concrete, slump 10 to 90 millimeters, flowable concrete, slump 100 to 150 millimeters, and highly flowable concrete, slump greater than 160 millimeters. The slump of concrete should be determined considering construction conditions, section dimensions of components, reinforcement density, compaction methods, etc. Cohesion refers to the ability of concrete mix components to stick together during construction, preventing segregation and maintaining overall uniformity. Good cohesion ensures that concrete mix does not segregate or separate during transportation, pouring, molding, etc., thus ensuring uniform internal structure of hardened concrete. Poor cohesion in concrete mix results in honeycombs and pockmarks after hardening. In large concrete mixes, even dog holes may appear. Water retention refers to the ability of concrete mix to retain water and prevent its separation. Concrete mix with poor water retention allows water to easily migrate from the interior to the surface, forming channels, which reduces the compactness of concrete and leads to shrinkage cracking, ultimately reducing its strength and durability. Water retention reflects the stability of the concrete mix. Everyone, please look at the left picture where concrete mix exhibits segregation and bleeding, with exposed aggregates and sand separation, indicating poor workability. After adjustment with admixtures, the concrete performance improves in the right picture. Concrete with poor workability tends to develop honeycombs, pockmarks, voids, and even exposed reinforcement after hardening, affecting the quality of construction projects. The fluidity, cohesion, and water retention of concrete mix are interrelated yet contradictory, These properties are not mutually consistent under all circumstances. For example, increasing the water content can improve the fluidity of concrete, but it may not necessarily enhance its cohesion and water retention. Good cohesion often corresponds to good water retention, but when fluidity increases, cohesion and water retention tend to decrease and vice versa. Good workability of a concrete mix means achieving good performance in all three aspects under specific conditions, thus reconciling contradictions. In general, using more water tends to decrease the strength and quality of concrete. Therefore, workability cannot be assessed by a single criterion. It requires a comprehensive evaluation based on several indicators. Workability of concrete mix is typically assessed by measuring its fluidity, supplemented by empirical evaluation of cohesion and water retention to determine workability. The fluidity of concrete mix should be measured according to GB/T50080-2016, Standard Test Methods for Performance of Ordinary Concrete Mixes. The magnitude of fluidity is indicated by the slump, or VB Consistency Index. The slump test is applicable to concrete mixes with maximum aggregate size not exceeding 40 millimeters and slump values not less than 10 millimeters. The VB consistency test is used to determine the workability of stiff concrete mixes. Alright, today we focused on explaining the concept of concrete workability and the standards for good workability. We also introduced methods for testing workability. Now let's think. Under what circumstances should the slump test be used for concrete slump measurement? And when should the VB consistency test be used? All right, that's it for today's lesson. Thank you.